So let's go over some relative motion examples, starting with what is relative motion and then how we can use it. So when we talk about relative motion, we're talking about the motion one observer sees compared to the motion another observer sees. So here we're going to take our stationary observer. Our stationary observer is going to be person A down here. And there's this truck, which is going to be the frame relative to A. All right? So the truck's going to move relative to this person A here. But person B is standing on this truck, so person B moves with the truck. So what we would see, if we're looking at what person A sees after some time passes, the distance is going to be the distance of B measured from the truck, and the truck in this case is our reference frame, plus how far did the truck go? Well, that's this, which is the velocity of the truck, which is the frame, relative to person A, times time, because velocity times time is equal to distance. And then person A measures B's position right here. So this is the position of B as measured by A. So it's always of measured by. So position of B measured by person A. So if we look at this and compare it, we get the position of B as measured by A is wherever B is standing on the truck, which is the moving frame, and again, the frame doesn't accelerate. A frame is equal to 0. It's an inertial reference frame. Plus, however far the frame moved in that time period. So, if we were trying to find velocity, velocity is the time derivative, so the velocity of B as measured by A is equal to the velocity of, here I'll use a different color, is equal to the velocity of B relative to the frame plus the velocity of the frame relative to A. This would mean that person A sees B moving, so the velocity of B as measured by person A equals the velocity of how fast that truck is moving plus how fast B is moving on the truck. And one other way that I like to note about this, B is the first letter, B is the first letter. A is the last letter, A is the last letter. And then the middle letter, which happens to be the frame, goes in the middle. So if you pair up your middle letters, it'll only work one way, and that'll tell you where this plus is going to be. Side note, it should also be worth noting that if person A is walking this way, person B is standing here, A sees themselves moving to the right, or A, they throw something. Let's say they throw this ball. A sees the ball going to the right, B sees the ball coming at them. So in this case, A sees the ball going away, B sees the ball coming at them. So one important thing to note is that the velocity of A as observed by B is equal to negative the velocity of B as observed by A. So if you switch these indices, if these switch, you just get a negative sign. And that's just because one person sees it moving towards, one person sees it moving away. So let's do a couple examples now. So I'll let you pause this, read it, and then solve for what these are. So elephant to the train, this is 3 meters per second. The train to the platform is negative 2 meters per second because it's moving left. An elephant to the train, well, we need to solve for this. So how do we arrange this? Take a moment, try it, and then we'll see you on the next slide. All right. So hopefully what you got is the velocity of the elephant relative to the platform is equal to velocity of the elephant relative to the train plus the velocity of the train relative to the platform, which is equal to 3 meters per second plus negative 2 meters per second, so that you get the velocity of the elephant relative to the platform is equal to 1 meter per second. And again, this is just happening because the train is moving towards the platform, elephant's moving away on the train, so overall you see it moving person on the platform would see the elephant moving away at 1 meter per second. Also very important, match the middle terms. So now we've got a person moving relative to the platform, and I want to find the velocity of the elephant as measured by this person. So if we recall the last problem, the velocity of the elephant relative to the platform equals 1 meter per second. And I'm giving you the velocity of the person relative to the platform equals 1 meter per second. Oh, but we can tell that these indices don't match. We can't mix them. So let's flip this one real quick. So we know that v person, or platform to the person equals negative 1 meter per second, because you just flip the sign. Flip the sign when you flip indices, because now we see it going the other way. And we get velocity, elephant to the person, equals velocity, elephant to the platform, plus velocity, platform to the person, which equals 0 meters per second. And it looks like the elephant's just standing there because the person's moving the same speed. It's kind of like two cars going down the highway. They stick with you forever, as long as they're going the same speed. And then you wonder why they're following you. But enough of one dimension. Let's go to 2 dimensions. And the examples in 2 dimensions will be shown in the next video, the sequel.